Yeah, that's the pond here in Texas this morning. It's what's it, January the 24th or something like that, Thursday. I think it's Friday. But anyway, I thought we'd do some shooting here and some talking about some things. We're going to wrap up everything basically in a ball right now. And when I say a ball, I mean a ball. There have been three major breakthroughs in our observation of the universe and how things happen and how we can predict motion and everything. One was, of course, with Copernicus. That was a real breakthrough. He saw the stars going over the sky and the moon going over the sky and the sun going over the sky, and he saw some retrograde motion in some of the stars, and he came up with a system which we know now as the solar system that explains everything. Then came Galileo and rolling balls and motion, talking about motion and inverse square. Of course, Newton then came up with his formulations along with the German fella who also gave us, basically he gave us not only calculus, both Newton and the other fella, but the other fella gave us, of course, binary approach to counting, which now is what computers work on. Give him full credit for that. He didn't add astronomy into it like Newton. And Newton with his falling apple, that is the motion of an apple, and the idea that this apple, as it falls, could give us information. Now where we're going to our next step. Newton gave us two laws of motion. Actually, you know, he put it in a form of three laws of motion, but there was only two basic visualization of motion, and the third is mostly, you know, math and everything. Okay, the first law of motion is that everything is in motion. Everything. And it starts on an electron basis, a binary system, all the way up to the very complex systems of atoms and molecule structures, big as the planetary system, the sun. Okay, now what we're talking about here, of course, is the third law of motion, and we have been talking about it, as you know, and we're saying that precession is very important. Okay, if precession is very important, that means that every time everything is in spin, and every time that you transfer energy or mass, or however you want to look at it, from Einstein on, you're going to apply into the other mass an inertia. Okay, you're going to put in energy and mass, transmigratory mass into the structure, and it's going to be in the form of an inertia to one side or one area of this overall molecule, however large it wants to get, such as the sun or something like that. Okay. Pond is absolutely gorgeous, and as we can see, we're going to walk on down here, take a look at the gases that are coming up, such in the way of water vapor from the pond. Now this is very important, because this shows us that gravity is not an overall event going on here. We don't have everything, attraction at a distance or attraction even up close. We have some very complex things going on, and the only thing that would explain these gases, is the third law of motion, and that is the acceptance that precession is the third event, is the event that you can count on every time. And when I say precession, forget all that other claptrap that they talk about. We're talking about a fundamental observed movement of a spinning top on a table, you could say. Touch it, and it's going to move to the right if it's spinning right. If it's spinning left, it's going to move to the left. And there, voila, right, left, up, down. It's going to explain everything. And it's going to explain one thing that Hamilton is going to propose. It's going to also explain why everything in our universe is a ball, a giant ball. The sun is a giant ball. The earth is a giant ball. The moon is a pretty good sized ball, and you've got a lot of balls out there. Okay, except when we get onto the structures of the earth, there's smaller things. We're going to see meteorites, rocks, you know, junk like that, all the other stuff we see. It's going to be less a ball. But it's going to finally wind up on a ball. But why does mass continually become a ball? Well, if we're looking at this event as precession is the major third element of motion, then we're going to see that every atom that makes up a molecule, every molecule basically that will then be affected by the atoms it makes up, the earth, the moon, the sun.